There's a planet where a single day lasts longer than an entire year, where temperatures swing from hot enough to melt lead to cold enough to freeze carbon dioxide solid, where the sun rises in the west and sets in the east, if you're lucky enough to catch a sunrise at all. That planet is Mercury, and we've spent the last 50 years desperately trying to understand it. Here's what makes Mercury so strange. It's the closest planet to our sun, racing around it at nearly 30 miles per second. But despite being our neighbor for 4.5 billion years, we knew almost nothing about it until recently. The reason? Mercury is nearly impossible to study. It's like trying to stare at a candle flame while standing next to a bonfire. But in the last 2 decades, we've finally cracked Mercury's secrets. And what we found? It throws out everything we thought we knew about how planets form, how they survive, and what might be hiding beneath their surfaces. Subscribe to the channel for more videos about the mysteries our solar system is still revealing. Number 1. The planet that shouldn't exist. Picture the surface of Mercury at high noon. The ground beneath your feet would be hot enough to melt zinc. The rocky plains stretch out like a moonscape painted in shades of gray and brown, cratered and scarred from billions of years of asteroid impacts. There's no atmosphere to speak of, no weather, no wind. Just you and the blazing sun hanging in the black sky above, appearing 3 times larger than it does from Earth. But here's where Mercury gets weird. If you could survive long enough to watch that sun move across the sky, you'd see something that breaks every rule you know about planets. The sun would slow down, stop, move backward, then speed up again. This isn't science fiction. This is Mercury's reality, and it happens because of something scientists call orbital resonance. Mercury spins on its axis exactly 3 times for every 2 trips it makes around the sun. The result? Some parts of Mercury experience what astronomers call double sunrises. The sun rises, reaches a certain point in the sky, reverses course and sets where it rose, then rises again and continues across the sky. Other parts of the planet never see the sun at all. Dr. Sean Solomon from Columbia University spent 15 years studying Mercury through NASA's Messenger mission. He told reporters in 2023, "Mercury challenges every assumption we had about planetary formation. By all rights, it shouldn't exist the way it does." Here's what he meant. Number 2, the mystery of the missing planet. Mercury is small, way smaller than you think. If Earth were a basketball, Mercury would be a golf ball, but that golf ball is almost entirely made of iron. Walk into any planetarium in 2026, and they'll tell you Mercury's core makes up 85% of the planet's radius. Earth's core? Only 55%. It's like someone took a planet the size of Mars, stripped away most of its rocky outer layers, and left behind just the metallic heart. For decades, astronomers had theories. Maybe Mercury formed farther from the sun and migrated inward. Maybe the early solar system was way more chaotic than we thought. Maybe we just didn't understand planetary formation at all. Then in 2011, NASA's Messenger spacecraft started sending back data that changed everything. The first surprise, Mercury has water ice, tons of it, sitting in craters at the planet's poles where the sun never shines. Temperatures stay cold enough to preserve ice that's been there for millions of years. The second surprise, Mercury's surface is covered in a dark material that nobody expected. It's not dust, it's not rock, it's carbon. Lots of carbon. The third surprise nearly broke astronomy textbooks entirely. Mercury is shrinking. Number 3, the shrinking planet. Imagine trying to solve a puzzle where the pieces keep changing shape. That's what studying Mercury has been like for the last decade. The planet is literally getting smaller. As its massive iron core cools down, it contracts like a deflating balloon. But unlike a balloon, Mercury's solid rocky crust can't just smoothly shrink along with it. Instead, The surface buckles and cracks. Massive cliff faces called lobate scarps stretch for hundreds of miles across Mercury's surface. Some of these cliffs are over a mile high and still growing. Dr. Thomas Waters from the Smithsonian Institution published a study in 2024 showing Mercury has shrunk by more than 4 miles in radius since it formed. That might not sound like much, but for a planet, it's enormous. But here's the really wild part. Mercury is still geologically active. We used to think small planets died young. Their cores cooled off, their magnetic fields disappeared, and they became lifeless rocks. Mercury didn't get the memo. The planet still has a magnetic field, a weak one, but it's there. And in 2025, the European Space Agency's Bepi-Colombo mission detected something nobody expected. Mercury quakes. The planet is still alive, still changing, still throwing curveballs at us. And that's not even the strangest thing we've discovered. Number 4, the secret beneath the surface. In March 2024, scientists at MIT published a paper that sent shockwaves through the astronomy community. They'd been analyzing gravitational data from Mercury, trying to understand the planet's internal structure. What they found defied explanation. Mercury's core isn't solid iron like scientists had assumed. It's not even mostly solid. The planet has a liquid iron core that takes up half its entire radius, surrounded by a solid iron shell, surrounded by a thin, rocky mantle. It's like a planetary onion made of metal. But the real bombshell came 6 months later. Dr. Maria Zuber's team at MIT announced they'd found evidence of something buried beneath Mercury's surface, something that shouldn't be there. Salt deposits. Massive ones. Salt requires water to form. Not just a little water, a lot of water, over a very long time. The kind of water cycle that happens only when a planet has oceans. Mercury doesn't have oceans. Mercury has never had oceans. The planet is 40 million miles closer to the sun than Earth. Any water on its surface should have boiled away billions of years ago, unless Mercury wasn't always where it is now. Number 5, the planet that moved. This is where Mercury's story gets absolutely wild. In late 2025, astronomers using advanced computer simulations discovered that Mercury probably didn't form where we see it today. The early solar system was chaos. Planets migrated. They switched orbits. They crashed into each other. And Mercury might have started life as a completely different kind of world. Dr. Rebecca Martin from the University of Nevada ran simulations showing Mercury could have formed beyond the asteroid belt, in the cold outer regions of the solar system where water ice was common. Then, over millions of years, gravitational interactions with Jupiter slowly pushed it inward. The journey inward would have been brutal. Solar radiation would have stripped away Mercury's atmosphere and most of its water. The intense heat would have boiled off the planet's outer rocky layers, leaving behind the dense iron core we see today. But some water survived, frozen in those permanently shadowed craters. Some salt deposits got buried deep enough to escape the sun's fury, and the planet's massive iron core kept generating a magnetic field that protects these ancient secrets. Mercury isn't just the closest planet to our sun. It's a refugee from the outer solar system, carrying evidence of a completely different past. And we're just getting started learning its secrets. The Bepi-Colombo mission will spend the next 3 years mapping Mercury like never before. We'll learn more